Hello, enough people had misconceptions about the transformation parameter B that I thought I'd do a little video. Hopefully this really helps before our big test. So first, let's review the transformational form of the absolute value function. It is y equal a times the absolute value of b in parentheses x minus c plus d. Now, I'm not going to review all of the parameters at this time. I'm going to focus on b because that's where most of the mistakes were on the quiz. Here's what b does. It's a horizontal compression if the absolute value of b, in other words, the positive value of the parameter b, is greater than 1. And the multiplier, the factor, is always a factor of 1 over b. It's a horizontal stretch if the positive value of b is less than 1 by a factor of 1 over b. And of course, don't forget, if b is negative, it's also a horizontal reflection. Okay. So let's look at a simple example. In this example, here are the transformations to the parent function. We have a horizontal reflection. Now, it is important, it will save you a lot of headaches if you work left from right, and you won't forget things like that negative sign. A lot of you did not see the negative sign because you didn't work left to right on the quiz. Then we have a horizontal compression because the positive value is 4 is greater than 1, and it's a horizontal compression by a factor of 1/4. Next, because b is already factored out, we see that we have a horizontal shift to the right 2, and finally we have a vertical shift up 3. Now that's the simplest example where b is already factored out, but sometimes the parameter b is not factored out. For example, we could take the previous example, we could do the distribution, we could distribute -4 across x minus 2, and that same function could be written like this: y is equal to the absolute value of -4x plus 8 plus 3. Now that's the same as our first example. Now what? I can't emphasize this enough. If you have an absolute value function that has a b value and it's not already factored out, make sure that you factor b out, negative sign and all, before you evaluate transformations. Let me say that again. Say it with me. Factor b out. It might already be factored out, but if it's not, factor it out, negative sign and all, before you do anything. Here's an example. We have the absolute value of -1/3 x plus 6. Now here we see no parentheses, so we know that b is not factored out. We need to factor it out before we can evaluate the horizontal shift left or right. So let's do that. If we factor -1/3 out, remember to include the negative sign in your factoring, then we get the absolute value of -1/3 times x minus 18 minus 1. Now we can evaluate this for its transformations. We have a horizontal reflection because I know you all started left from right, and we notice that negative sign. That doesn't exist in the parent function, so it's a transformation. We have a horizontal stretch by a factor of 1/3 because the positive value 1/3 is less than 1. Now we see that we don't have a shift left 6. What we really have is a horizontal shift right 18. And of course, we have a vertical shift down 1. For those of you wondering how we went from a plus 6 to a negative 18, here's a little review of fraction math. All right, to factor negative 1/3 out of 6, we have to divide 6 by negative 1/3. Now, you may have learned in middle school or elementary school the phrase, keep it, change it, flip it. We keep the first term, the 6. We change the division to multiplication, and we flip the fraction. So that becomes negative 3/1. 6 times negative 3 is negative 18. That's how we got there. Let's look at an example from another direction. What if you had to write the transform function if the parent function has been horizontally compressed by 2 and shifted left 4? Well, you could just write it in factored form and be fine. Or you could write it like this. You could distribute the 1/2 across the parentheses and write it like that. And in either case, you would have the correct answer. Now, if you have questions, you want to see me for tutoring as soon as possible. All of the transformation parameters are universal across functions. So it's best to invest now and learn them, and you'll be in good shape in this area for the rest of the year. This is Mrs. Clark signing out.